channel, and today we will be designing a BookMyShow. So in this video we'll see how BookMyShow's architecture really looks like, or if we say any other ticketing software's architecture, what it looks like and how can we build it and scale it. Okay, so this video will be little bit lengthy, but we will be discussing in deep about how this booking systems works. Okay, so stay tuned and watch till the end. Starting with our functional and non-functional requirements. So our functional requirements are simple. Just we have to search any movie or event for any location. We can browse there, see their details and all. And third is we can book our tickets if they are available. Okay, and non-functional requirement, it should be highly available, it should be consistent, like no two users are allowed to book one single seat, and low latency of search and booking should be there. And yeah, if there is when one very popular show or movie happening, so there can be a surge of traffic, very high traffic, so our system could handle that as well. Okay, so let's start. As we follow in all our videos, we start with one basic simple design and then solve our problem step by step. Okay, so as we can see, there will be obviously a load balancer, plus we also applied rate limiting to this load balancer to check a fraud for fraud checks. There can be chances that there is a DDoS attack, so our system can handle that attack. So rate limiter is very important here. I will be covering a separate video of how rate limiter and load balancers are designed internally and how it works. For now, let's begin. Uh, we'll be having one API server which will be handling all our functional requirements, which is for searching movies, or if we want to do any kind of updates on that move events, like for backend systems also, booking, search, everything will be handled by this API server. We have taken a SQL DB here. Okay, and SQL DB because we want consistency here, and consistency is the key, so that no two users are allowed to book one single seat. Plus we have also added a cache node so that we can cache some result and make a read faster. Okay, so what our architecture will look like for a DB. So this is a basic architecture. There are many more tables which we can add. So for now, just for example, I have created these. I will be creating another video for low level design, or you can say DB design or class object design of BookMyShow. There I'll explain more in details what attributes and what tables we can have. Okay, so now let's suppose this is an event which, and we have venue, and a show is something which is happening at an event, at a venue of that particular event. Okay, and what all seats we can book for that particular show, we have that detail in show seat table. By default, the status will be available, and if any user comes and try to book, we will mark that status as booked. Okay, so we can have this Postgres or MySQL, if we are using, we can have their locking functionality here, so that only one user is allowed to update or book this seat. Okay, so this we can use, but in this design there's many problems, like obviously it is a monolithic architecture, I think, which is not required, because we can see there will be an API for search which will be used most of the time by all the clients, so the throughput of that API will always be higher, and if we want to scale that, we will not be able to do it. And if we're comparing that with booking APIs, or and there can be another APIs which can do CRUD operations on event, like if we want to create an event, we want to create a show, that kind of APIs are also in this API server, so which will be called very few times, so the throughput will be very low in compared to other booking APIs or search APIs. So I think we can have a microservice architecture here. Okay, and also there is an issue like if two users at the same time comes to book a particular seat, only one is allowed to book, and second we'll send an error. This is a very bad customer experience, and this in this design we are not able to solve that experience also. So we will create a more scalable design and try to solve all these problems. Okay, this is a more scalable design. Okay, so what here we have done is we have created a different search service so that we can scale it differently. We can have multiple instances of this service, same with booking service. And this is a CRUD service which will only be responsible for doing CRUD operation on a database or on our events or for creating shows. That kind of operation is are done in this CRUD service. Second is booking service, which is responsible for booking a seat for a particular user. And third is a search service, which is responsible for searching a event for any city or for all the events which are happening or selecting one event, like all kind of search we can do on this search service. Okay, so what else we can do here is so see we have solved a problem of scaling, but the problem where two users are coming to book one single seat and one it is failing, we have still not solved that problem yet. Okay, so the earlier problem was, let's suppose the payment is done. So the problem was when payment is done and two users are coming to book the seat, we are not able to, we are not allowing them. Okay, so after payment, this experience is very bad for the customer. So what we can do is we can add an intermediate state uh, which will be used for uh, allocating that particular seat to user before payment. Okay, let's say we have one reserved status. Okay, so what will it do is as soon as we'll select a seat, user select a seat and click on book now, we will uh, mark the status of this show as reserved. Before that, there's one thing which I missed is how this show seat table is created. So what we'll do is as soon as one show is created, it will have a date also. No? So as soon as one show is created, uh, we will make entry for all the seats which are available for that show in this table and mark it as available by default. Okay, so for that particular show, we have created different entries for different tables and we have marked as available, and this will help us to show the inventory, or it will help us to show user that what all uh, seats are booked and which all are available. So we can take use of this table only for that purpose also. Okay, and now as soon as user selects their seat and clicks on pay now, we will mark this seat as reserved so that another user is not allowed to reserve this seat until and unless their payment failure or success. Okay, so as soon as this booking service will mark this reserve, we can trigger payment for, we can have one payment service also for that. uh, okay, so as soon as payment is confirmed, this will tell this booking service, hey, my payment of this user is confirmed for this particular booking. So this booking service will mark it as booked. Okay, but here's one edge case. Let's suppose user has clicked on pay now, but he then kills the app or goes back to the home page and all the payment is never done. What in that case, what will we do? So we will make a cron. This cron will run every 5 to 10, 5 minutes or 10 minutes, Let's suppose we are running at 10 minutes, and it will see that is there any status which is marked as reserved for more than 10 minutes. It will mark it as available. So for this we can have one more row or one more column, and call it reserved at column. This will be a timestamp which will tell that at which time this seat was reserved. Okay, so based on this key we can say that if 10 minutes have passed, we will delete or we will make that seat available. We will delete their reservation. Okay, but again, is this the best way to do it? Is this the complete solution? No. First problem here is we have created different services, but our database is same, which is not a correct way, because this can create a bottleneck and it is a single point of failure also. So there is no way that we have achieved, like if this DB is down, all our services are down, nothing will work. Second, let's suppose our cron is running at every 10 minutes. So at 5 o'clock, the cron ran, and some user has come and it has created at 501 entry at 501. Okay, so now as soon as when next cron will run at 510, it will see that reserved at time of that particular seat is 501, which is only 9 minutes. So it will never mark this as it as uh, available. It will leave it and it will go forward. So when it will come at 520, it will see, yeah, now this 501 is more than 10 minutes, so we can mark it as available, which is again not good, because we are saying that we will free that seat in every 10 minutes, but in this case it is 19 minutes in which this seat is becoming available, which is again a bad customer experience. Okay, so again we are not able to solve the customer experience part, plus we are not able to do scaling also. So what else we can do? So this is the more better way to design it. So what all we have done here is, so this SQL DB will contain all the information related to an event and shows. Okay, so CRUD operation will always do operations on this DB. It will not do any other thing. We will not say booking details in this DB. Okay, so we'll say booking details in this booking DB. So how this booking details will come? Okay, so as soon as the show is created, we'll push a message in this queue, and this consumer will consume the message from the queue, and it will create entry for that seat. So all the show seat entry will be created in booking DB. Okay, plus it will also have one booking table. If one booking is done, it will have the all the booking related details and booking seat IDs also. Okay, so yeah, so we have now have two different databases for both booking and CRUD service. For search, since search here is will be very slow, because it will be doing like operations on our SQL DB queries, which will become very slow when we have millions of events or shows happening all over the world. So this is not acceptable. So what we'll do is we will make use of Elasticsearch, and we will update this Elasticsearch using CDC. So what is CDC? CDC stands for Captured Data Change. So this is a pipeline which we build using queues again. So as soon as there is some update in our DB, we will push one message and it will update the Elasticsearch index. So how Elasticsearch works? Okay, I'll create another video of Elasticsearch in depth how it works, but on uh, I can give you an overview. So in Elasticsearch, it saves data in a JSON format. where it do inverted indexing. Like we can mention some keys or keywords at which it will mark that index, mark that document as index for that keyword. So that keyword is pointing to that particular object. Okay, and we can also do text-based searching here easily on Elasticsearch. Now, question comes, if Elasticsearch is this optimized, why are not we using as our main DB, and why are we using updating entries here using CDC? So see, Elasticsearch is good for only search applications, not for persistent storage, because it is not durable. So that is why. Also, one catch is here, like Elasticsearch do there some kind of caching for keyword which are frequently accessed. So we don't need cache here. Okay, but yeah, we are maintaining a lock cache here. So what this lock cache will do? Okay, so what we can do here is, as soon as user will click on for now are this thing of scalability is pretty much solved here. We are able to scale. There is no single point of failure also. Okay, so every responsibilities of different services is being divided properly. There quick search is also happening, but our customer experience thing is missing, which we have to solve. So how we'll solve that? So we'll solve it using a log cache. Okay, so what we'll do in log cache is, as soon as there is one booking, a user clicks on pay now after selecting their seats. In this cache, we'll mark the we will write that seat IDs, or you can say show seat IDs, and add a TTL there. Okay, so as soon as another user comes and try to add those show seat IDs, it will see that it is already that show seat IDs are already in cache, so it will not allow. Second is that if we are added TTL of time. TTL stands for time to live, which is an inbuilt feature of cache. So if we are added a TTL of 10 minutes, so what Redis will do is, okay, so we are using Redis cache here. So what Redis does is, it deletes that entry after 10 minutes. So Redis cache is a key value pair. I will again create a video of different type of cache we have, what and how Redis is used, when Redis is used, and how internally Redis works. Okay, and why Redis is so much fast, why we use for caching. So I'll create a separate video on that as well. Okay, so yeah, so for now, there's we can have a lock on seat IDs, which will be having which will have a TTL. So since seat IDs is present in this cache, so that no one else will be allowed to proceed for booking, as there's as someone else has uh, logged that seat for them, reserved that for them. So we don't need now this reserved status here. We will only need booked and available. Okay, we also don't need that cron, because it will delete it by itself automatically. Okay, and when while showing what seats are not booked, so we'll show every seat which is available here, but we'll also minus those seats which are in this cache for that particular show. So this we'll do in the application, the code itself. Okay, so like this we can achieve all our functional and non-functional requirements. If you say that this design, if you tell the design in any interview, you will get selected, because if you tell this design also, you will get selected for medium level of roles or starting roles. But if you are going for a staff level interviews or senior level principal engineer interviews, this design is what interviewer expect from you. There's some scope of improvement here also. For example, what if payment is confirmed and they try to tell the booking service, but booking service is down, what can we do? So in here we can, what we can do is we can create a queue which will tell, which will update this booking status to booked from available through consumers. So if this booking service is also down, our booking are getting accepted after payment is completed. Okay, so yeah, these kind of enhancement is still we can do in this design. There are few more which we can do based on a requirement, based on how product requirement is there, how what kind of client base we are having. That all we can do, but yeah, this design is also complete in itself. Okay, I think this you have understood the design properly. I hope so. And yes, do let me know how is there any improvement which I can make in my explanations. Did you like the video or not? And also let me know if any other question you want me to prepare design of. I'll do that also. Okay.